السلام عليكم ورحمة الله وبركاته. صبحكم الله بالخير جميعا. نكمل إن شاء الله chapter 10 and we will take example 10.2. In example 10.2 we will redo example 10.1, but this time using the discounted profitability analysis. Let's recap. In example 10.1 we have calculated in details the cash flows we have at each year and the cumulative cash flows. Okay, so I will solve this problem through Excel, and I will take these two columns that we have developed or calculated in 10.1, and I will take it into Excel. This is Excel. This is the number of years. These are the number of years and corresponding cash flows in each year. Okay, remember that this value here at year 12 is the cash flow that we have generated in year 12 plus the salvage value and working capital. This number here, the 70, is equal to actually our working capital. Our land is equal to 10 plus our working capital is equal to, I think, 30, and our net income or net profit in year 12 is equal to 32.25. All right, so I will divide my Excel sheet into two sections. The first section is called the non-discounted section, and it's this one here, and the other one is the discounted section, which is the other one here. I will first calculate my cumulative cash flow for both sections. Well, let me finish up first with the non-discounted section. So my cumulative is equal to my previous year's cumulative cash flow plus this year, and I do the same for all the years, and that's how much. Let's forget about these numbers because we're going to calculate them ourselves, and that's the cumulative cash flows. Now, one important values we need also to come up with is how much cash we have generated from the project, and we don't start generating until year 3, and the amount we generated in year 3 is equal to 38.25. Let's calculate how much we accumulated across the years of what I call positive cash flows. So it's the previous year, how much I generated from previous year, and add to it how much I generated this year, and so on. I will stop at year 12, and then at year I will stop at year 11. At year 12, I will add to the previous year's cumulative cash, positive cash, or generated cash. I will add only 32.25, as that's the amount of, or another way I will add how much I generated in year 12, or how much cash flow I have in year 12, minus 10, which is the land, minus 30, which is equal to the working capital. And that's how much I have in positive, how much I generated, how much generated cash I have accumulated in each year. Okay, so far so good. All right. Now we're done with the columns we need for non-discounted analysis. Let's talk about the criterias or the criterion. The criterion is 1. The criteria is for plural. So the first one is cash or cumulative cash position, and that's equal to how much I have at the end of the project in cash flows, and that's equal to 170.51. The cumulative cash ratio is equal to the sum of all positive cash flows divided by the absolute value of the sum of all negative cash flows. And why am I taking the absolute? Because this number is cannot be negative. It's a ratio that is positive, so the number is, the value is 1.89. The larger the number, the better or the more attractive this project is. Payback period, well, the payback period, you have to look at this column here, and that's exactly why we developed this column. You go down across the column until you find the number equivalent to your FCI. That's your FCIL, 150 million. So clearly we start getting my fixed capital investment back at around year 6. Year 6 is around 4 years after startup. So this is the first year after startup, this is the second year after startup, third year and fourth year. So roughly speaking, it's 4 years after startup. This is years after startup. Okay, but if I want to be precise, I have to do interpolation. I have to interpolate. Excuse professors laughing. Okay, so we have to interpolate, and to do interpolation, we know it's equal to year 3 after startup. Year 3 after startup. All right, and then we have to interpolate. We're looking at the value 150. That's the number we're trying to interpolate, or to find the precise year at, minus 122.3 divided by the whole range that we have, which is equal to 154 minus 122. If you lost, please go look up interpolation in YouTube, and you'll find out what I'm talking about here. So the answer is 3.85 years. This one in dollar, and this one also the real, I don't know, dollars. I think CCR is dimensionless. Okay. Okay, done with the non-discounted analysis. But let's do the discounted now. For cash flows, now we know we have negative $10 million in cash flow in year 0, but we have to adjust it for the discount rate. And to do that, we have to convert from future value to present value. That's discounting to present value. We divide by, if you go to the table or go to the previous chapter, it's divided by 1 plus the discount ratio. In this case, it's 10% to the power n, and n here is equal to 0. Clearly the answer is -10 because at the present time cash flow is equal to discounted cash flows. Okay, well, when you drag, you have to make sure that R is fixed. So now we can drag, and this is the cash flow. To calculate the accumulated cash, discounted accumulated cash flows, we add the previous year cash flows to this year's, and that's what we get. Positive cash flow does not start until year 3, and these are the values, similar to the one we've done before, and we drag this one here, and I will stop in year 11. I don't want to worry about year 12 because these values should be sufficient to calculate our criteria. All right, done. All right, NPV, net present value. Net present value is analogous to CCP, cumulative cash position, but this time we are discounting. So it's the same value that we took from the previous, from the cumulative cash flow in the non-discounted section, but this time for the discounted section. So NPV is equal to 17.3. Let's double check our answer from the slides. If we go here, NPV, it's 17.12. Okay. All right. How about PVR, present value ratio? You do the same as you've done before. You sum all positive cash flows and you divide by the absolute value of the sum of the negative cash flows, and the number is 1.1. Let's double check our answer. The answer is I think it's 1.10. I think it's correct. So let's proceed. All right, discounted payback period. This is analogous to this one here, payback period, but this time for the discounted. So we have to go down through this this column and find the discounted, the FCI. There's a tricky part here, which is previously we were looking for this number here, 150. We went down the column until we found 150 million. Now this time we are not looking for 150 because we have to adjust the 150. We have to adjust the 150, and now we have to adjust it for the discount rate. And to do that, we have to take our investments. So we invested the first 90 million. So 90 million, we invested it in the first year. So we have to divide by 1 plus R to the power 1. That's the first year. And the second year, we invested 60 million. Okay. We invested 60 million from the FCI. They add up to 150 million, but we have to adjust it for discount rate, 1 plus R to the power 2, because this is invested in year 2. So now the number we should look for is 131. So we go down until we find 131. Currently, it's around year 8, which is 6 years, around 6 years after startup. But I want to be precise, so I will do interpolation. So 5 plus the number I'm looking for here is 131.4 minus 118.9. Let me use the cell. Okay, divided by the whole range. The whole range, this one minus this one here. That's the way we do interpolation. That's equal 5.9. Let's double check our answer. Payback period 5.94. 5.94. That's the correct answer. All right. Now, these are the numbers for your first 3 criteria. Now we come to the discounted rate of return, and the way we find it, we start adjusting this value here until we get our MPV equal to 0. So our target is to get MPV equal to 0. This MPV, our target is to make it equal to 0. So if we change this to 0.11, that's not good enough. 0.111, that's not good enough. 0.12, that's close. 0.121, that's close, I think, enough. But let me, if I want to be paranoid, I will try 1.12. That's in the negative side, so 0.111 maybe. Yeah, that's good. So your rate of return is, your discounted rate of return is equal to 12.1%. Let's double check our answer, and the answer is correct. It's 12.1. Now you have to be careful when you use Excel, because when you change this number, all other numbers will change. Okay, and you probably need to keep the 10% first, and then copy these values and copy them here as values. So these are the correct values here, and this is the MPV that you keep iterating. So now I can start changing 0.121, and MPV is equal to 0. All right, so let's go back to 10%, and I will take these values back here. Okay, this 0.1. This is my answers. These are my answers. Okay. All right, let's go back to our lecture. So this covers most of what I wanted to cover in this chapter. A few things to cover in this chapter before we move into our next chapter. So 10.4. All right, the next section, which deals with how do we evaluate alternatives if we have different projects. Okay, let's say project A, okay, and project B and C. They have different initial investments. So the first one is 60 million, the second one is 120 million, and the third one is 100 million. We do the economic analysis, and that's what we come up with. We know the cash flows from these projects. The cash flows in the first year is equal to 10 million. for project A, and in the second year up to year 2, up to year 10, the cash flows is equal to 12. All right, fair enough. This is the information you need to do profitability analysis. Okay, so we can proceed similar to the Excel sheet we've done. We can proceed with the profitability analysis, and these are the numbers we get. This is the table that you should focus on. You get your NPV based on your company's 10% discount rate. Your NPV is equal to 11.9 for the first project, and 15.2 in the second project, 15.6 in the third project. If you do the discount rate of return, these are the numbers you come up with. Now if I ask you a question, which one you should select? If you have $120 million to invest, which project you should select? Well, unfortunately, with 120, remember this project cost 60 million. This one cost 120. This one cost $100 million. So you would not be able to select multiple projects. All you can do here is select one, and this is what they call mutually exclusive. So you cannot choose more than one. So if I take NPV, the one I would select is C. If I take this discounted rate of return, the one I would select is A. Okay, well, this is really confusing because I don't know which one to go with. The book shows you that now, since each project costs different amount of money, now the selection is not straightforward. If you take the discount rate, okay, your answer will be wrong. Because yes, you're making, in this $60 million, you're making 14.3%. But the additional money that is invested in Project C gives Project C an advantage. So when you compare projects, what you need to really use is NPV. That's the summary of this section. Now the example in the book illustrate using numbers how Project C is better than Project A, and you can go through it, but the takeaway is use NPV when you compare projects. For your information, 10.5 is not included in this course, so we will stop up to 10.4. I will post a homework that is due on Sunday. Remember, you have a quiz inshallah on Thursday. Wish you all the luck.